Okay. So in trigonometry, we will start with the very basics. Okay. I'll just quickly give you a brief about what all things we should know till now. So there are three trigonometric ratios, which are sine, cosine, and tangent. Okay. In general, there are six, but we can just start with three only. Sine, cosine, and tangent, these are the names. But when we say ratio, so it is with respect to a right angle triangle where this will be theta. With respect to theta, this will be opposite. This is adjacent and this will be hypotenuse. So sine theta is O by H. So that is why we call it as so. Then cos theta is A by H. We call it as ka. And tan theta is O by A. We call it as TOA. So that is why we call it as ratios. Okay, just understand this thing that sine, cos, and tan, this SOHCAHTOA is trigonometric ratio. Now, what do we call it as trigonometric function? So when I say y is equal to sine x, this is a trigonometric function. When I say y is equal to cos x, this is a function. Similarly, y is equal to tan x is also a function. In this, x values represent the angles only, but these angles are usually kept in radians. So radian is a new unit which we have to learn. Okay. This is just like a comparative unit only compared to the degrees. So what they have done, they have considered the whole circle, 360 degrees, as 2 pi radians. This you can take it as a fact. So from here, if we come down to like dividing both the sides by 2, I will get pi radians is equal to 180 degree. And from here, we can get the conversions. Like if I need to get 1 radian, that will be 180 by pi degree. If I need to get 1 degree, that will be pi by 180 radian. Radian is usually written like this, like we use this power C. But when we are writing only radian, then this power C is optional. Sometimes you will also see radian written like this pi by 6. Pi by 6 is just an example. We need not write that power C to it. Now, what is this pi by 6? So, since we have seen that 180 degree is equal to pi radians, so I can first of all convert all the degrees, all the regular degrees into radians. So, I'll be using 0, 30, 45, then 60, then 90, then I'll take 120, 150, and 180. Okay. I'll be taking only these values as of now, and later on we can write for anything. Now 0 degree or 0 radian, they will be same. So in radian also it will be 0. But if I need to get 30 degree into radian, what should I do? 30 into pi by 180. That is how we need to convert. Okay, 30 into pi by 180, that will be pi by 6. Then if I need to convert 45 degree into radian, I'm waiting. Can anyone tell me what it will be?
So 9 by 16 pi. I mean 9 by 16 radians.
45
It's like 45 times.
pi by
Oh
180.
wait, sorry, by 180. It's 1 by 4. Sorry, yeah. 1 by 4 pi.
1 by 4 pi, yeah, sorry.
1 by 4 or pi by 4. Okay. Similarly, 60 degree. Just keep on calculating and just tell me the values fast.
Yes, sir.
That will be pi by 3. Okay. Then 90 degree.
Pi by 2.
Correct. 90 degree. You can see 180 is pi. Okay. So 180 by 2 will be 90. So that will be obtained by doing pi by 2. Then
2 over 3
180.
pi. 2 over 3 pi.
2 over 3 pi is correct. Now, what is the trick to write it faster, like without using calculator? So you can see that 60 degree is pi by 3 and twice of 60 is 120. So I can write it down as 2 pi by 3 or 2 over 3 pi. 150 is a multiple of 30. 30 times 5 is 150. Okay.
Can I do the same with the 180 then? Just do 2 pi over 2.
So we can write it down as 5 times pi by 6, 150. And then 180 will be pi only. Okay, wherever there is a doubt, you can just feel free to do this. You'll get the answer. Okay, there is one angle which I missed in between. That is 135. 135 is a multiple of 45. That is 3 times. So 45 is pi by 4, so it will be 3 pi by 4. Okay, so first thing is that you should get yourself used through with these notations. Okay, basically, when we need to convert degree into radian, we need to always multiply by pi by 180. How we got pi by 180? So this is the reference. Always remember this. Okay, your calculator can also give you the answer directly, so you can use that also. That is okay, but you should still understand that how it is working. So in this, if anyone have any question, you can ask.
No, sir.
No doubt, sir.
So we'll move on to few more conversions, okay, just for practice. So till now we have done 0, 30, 60, then 45 also we have done, 60, then 90, then 120, then 135, 150, 180. Next we are going to do 210, 225, 240, 270, 300, 315, then 330 and 360. I'm basically trying to write everything from 0 to 360, not everything, but these majorly used angles into radians. Okay, so everyone can write at their own speed. And if you want, you can just watch it from the screen. I am writing pi by 3, pi by 2. Now, if you are smart, you'll be learning only these. Okay, you need not learn any of them. Okay, now 120 is twice of 60. I'll write it down as 2 pi by 3. 135 is 3 times of pi by 45. So that will be 3 pi by 4. 150 is 5 times of 30. So that will be 5 pi by 6. 180 is pi only. Then 210. 210 is a multiple of 30. 7 times. 7 pi by 6. 225. Anyone?
Would it be 8 pi over what?
It's a
220
multiple of 45, sir. It's a multiple of 45. It's 5. So 5 pi, 5 pi 4 over 4.
Yeah, 5 pi by 4 is correct. It's a multiple of 45. 5 times 240.
60? Multiple
Yeah.
of 60?
We can take 60 also, 30 also, 120 also, whichever you like, you can go ahead with that. Usually I take 60. So it is 4 times of 4 times of 60. So it will be 4 pi by 3. 270 is a multiple of
90.
90. Better, we can use 90, but we can use 30 also.
So is it 3 pi by 2?
Yeah, it will be 3 pi by 2. Then 300.
Would it be
30. 30, 30, 30.
30
10.
or 60 will be better. 65 is
60, yeah.
300. So 5 pi by 3. But look, even if someone use 30 now, so they will do 10 times of pi by 6. They need to simplify this. 5 pi by 3. That is okay. 315.
So would it be for 45? So
Is the multiple of 45. How many times?
7 times. So 7 pi over 4.
Yes, it will be 7 pi by 4. Then 330.
Would it be for 30?
Yeah, it's 30. And it is 11 times. So 11 pi over 6. And 360 is 2 pi. Okay. Now the reason for doing this is when we will look at the graph, all the graphs have pi notations. Like all the graph have radian notation. They do not have degree notations. because degree is restricted only to 360. But when we are dealing with pi, we can actually move ahead from 2 pi, like 2.1 pi, 2.5 pi, and so on. So we can cover all real values with the help of radian notation, and that is the reason that we need to learn it now. So the main reason for learning this is we are starting with trigonometric functions. Till now, till your year 11, you have done trigonometric ratios. Ratios were SOHCAHTOA. SOHCAHTOA will be used in some questions, but it is not directly applied anywhere in functions. Okay, but it will be definitely used indirectly. So functions means it will be of the type y is equal to some fx. So this x needs to be kept in radians, and that is why we need to understand all these degree radian conversion. Okay, for degree radian conversion, the simple criteria is that pi radian is equal to 180 degree. From here, we can just give it a start, and that will give me 1 degree is equal to pi by 180. For all these, we have done this only. Wherever you see degree, you just multiply that by pi by 180, and the fractional part is written along with pi. Now the next part is quadrants. Now everyone keep your calculator handy, because I would just ask some random angles and I would like to know the sign of that. Okay, so quadrants, we have 360 degree that will be divided into 4 parts. So we have 4 quadrants. Okay, 4 quadrants are numbered in anti-clockwise manner: 1, 2, 3, and 4. First thing, this should be clear. Now, the second thing is 4 quadrants represent angles. So it will start from 0, then pi by 2, then pi means 180, then 3 pi by 2 means 270, and finally 2 pi means 360. If there is anything which exceeds 2 pi, let's say if I have 510 degree, for example. Okay, like initially we will be doing both degree and radian so that you can get used through with both the notations. 510 degree can also be written as 360 plus 150. Just verify whether I have written what I have written is correct or not. Okay, so 360 plus 150 will be 510. 360 means one complete rotation, so we'll rotate one complete time, and then 150. So for 150 we'll go again into the second quadrant. So 510 is an angle of second quadrant. Okay, this is how.
Sir, I have a question.
Yes,
What do you mean by 0, 2 pi?
that is not 0, 2 pi. It started with 0 degree and then it is ending at 2 pi because it's a cycle. Okay, it's whole cycle.
So do we just write 2 pi in the angle? Or?
Yeah, 2 pi and 0 will be same. It means that. Okay, like these are not coordinate axes. These are the just points which are representing 0 degree, then pi by 2, now 0 radian, pi by 2 radian, pi radian, 3 pi by 2 radian, and then 2 pi radian. So basically we start with 0 degree, 90 degree, then 180 degree, this is 270, and after 270 when we'll complete the whole circle, we'll get it as 360. So we are just trying to say that when we start from a circle, when we come to the same start point, we say one circle is completed. So start with 0, end with 360 means one circle is completed. That is why both of them are written together. Okay, mathematically they have different values, but when we put them in the function, they will give almost equivalent results.
Okay.
Okay, so first quadrant belongs to all trigonometric function. So we usually denote, like we usually write it down as A. A stands for all, and all means all positive. Now keep your calculators handy. You can use degree notations. So make sure your calculator is in degree mode. Okay, at the top of the monitor, you will find D, E, G or R highlighted. So if it is D, E, G highlighted, you can use it directly. Just find the
Sorry,
value
what, sir?
DEG.
On the top of the
Monitor,
calculator?
okay, like that screen is there, na? So in that screen, either DEG will be highlighted or R will be highlighted.
R is highlighted.
So it means it is in gradient mode. So you need to
Yeah,
change
because I
it
was
to-
just using it.
Yeah. Yeah, so you need to change it to degree mode. Anyone have doubt how to do it? How to change
I
into-
did it.
Okay.
No, sir.
Akbar, you have doubt?
No, no, no. I was saying I don't have a doubt.
Okay. And Rakeen and Samuel, have you converted that mode?
Yeah, sir. I've done that.
Okay, now I want everyone to just check the sign, okay? I don't want the value, but just check the sign of sine 36, cos 36, and tan 36. And just let me know whether all of them are positive or not. 36 have no logic. It's just a random angle in the first quadrant. You can choose any other first quadrant angle also.
So sine 36 is negative.
Sine 36 is negative. Check again.
Yeah,
It
it's
shouldn't.
in radians.
So your mode is in radians, you convert that to degree. Everyone, please put the angles in degrees. Right now, radians, we will like start using it, but gradually, not right now only.
Oh, okay. So I thought you were telling us to do in radians.
No. Do it in degrees.
Otherwise, it's positive. It's positive, sir.
It's positive. All three of them will come out to be positive. Just for verification, you can check for any angle between 0 to 90 degree.
Yes,
But
sir, they're all
0 to
positive.
90, don't include 0 or 90. Okay. Take anything between 0 to 90, whether fractional, decimal, or a whole number, it doesn't matter. Okay. So it will be positive. I hope everyone have seen it. Moving on to the next. In the next quadrant, we write sine. So this quadrant belongs to sine. It means that sine will be positive. Okay. Rest others will be negative. Now, what I mean by second quadrant, so second quadrant means angles between 90 to 180. So you start from 90 point something to 179.99999. Don't put 180. Okay. Boundary values we'll see later. So what I'm trying to say is that any angle between 90 to 180, let's say we will write 147. So you find the value of sine, cos, and tan of 147 and just check it out that only sine will come out to be positive, but tan and cos will be negative. Just check it out. For everyone, it should come as negative. Okay, so if anyone is facing problem, please ask.
Wait, sir. If it's between 90 and 180, does it always have to be positive as well, or only sine is positive?
Sine will be always positive. Sine.
Oh,
Sine means I'm talking about this sign. Okay, not SIGN.
yeah, sir.
Okay. So I hope everyone have checked the value of sine 147, cos 147, tan 147. Just check the sign.
Yeah, sir, sine is positive and then everything like cos and tan are negative.
Yeah. So then we can fix it that first quadrant belongs to all. All means every trigonometric ratio is positive, or in other words, all trigonometric functions have positive value. Second quadrant belongs to sine. It means only sine will have positive value, the others will have negative value. Likewise, when we move on to the third quadrant belongs to tan. It means tan is positive, rest all negative. So any angle of third quadrant, let us take 229. I'm taking any random angle. Find the values of sine, cos, and tan for 229 and check the sign of them. Like sine and cos should be negative, tan should be positive for this 229.
So tan is positive and the rest are negative.
Yes. So I hope everyone can see that. Okay, you can definitely try for whichever angle is coming in your mind. It should be between 180 to 270. Okay, and finally, the only one function is left, that is cos. Fourth quadrant belongs to cos. So it means cos is positive, and we will be checking it for 337 degrees. So just check the value of sine, cos, and tan for 337. It should come out like cos should be positive, the other should be negative.
Oh yeah, so you're right. All of them are negative and only causes positive.
Okay. Now in this diagram, like it is all cluttered, so I'll just make a fair diagram once again. Okay. So let us just quickly sum it up. So in the summary, we should know that these are the four quadrants. Okay. Four quadrants means 0, 90 degree, 180 degree, 270 degree, and 360 degree. Intentionally, I'm using different like degree notations now. Okay. Try to get used through with both the notations. As per the requirement, anything can be there in the question. First quadrant belongs to all. I'll just write A now. Second quadrant belongs to sine. Third belongs to tan. You can see that quadrants are also numbered in the anti-clockwise order because angles are measured in anti-clockwise order. Okay, so don't change this order, otherwise your whole analysis will be different. So A, S, T, and this will be C. There are a few ways with which we can learn this. Okay, eventually it will settle down in your mind, but initially you should learn it. So like this is all silver tea cups. This was the boring mnemonic, okay, to learn. There is one more simpler, and it was just suggested by one of the student 2-3 years back. And he suggested that after science, take commerce. After science, take commerce. I liked it, so I have started using it. So whichever way you would like to learn it, it is your choice. But you should know that first quadrant belongs to everyone, means every value will be positive. All trig ratios will be positive. Second belongs to only sine. Third belongs to tan. And fourth belongs to cos. Now we will prove it in the graphs also, because before moving towards the question, I will just discuss the graphs of all three of them. So let us move on. Is there anyone who is writing from the screen? Anything? Okay. Just go through the lecture videos also for this chapter, and you should go through it multiple times because these things will not be that much clear in one go. Okay, it will take some time. So you have that, like we can say, plus point that you can go through the video as many times as you want. Okay, so you should go through it later also before our next class. Next is graphs. We'll start with y is equal to sine x. Mainly, we should understand the graph for one cycle minimum, and then we'll see the pattern for other cycles. So the graph of sine x is like this. And this is repeated infinitely on both the sides. Why I'm focusing only on one cycle? Because one cycle is from 0 to 360. Now, since we have also learned degree measures like radian measures, so we are not restricted to one cycle. We can actually see the graph of sine like this. But for analysis, we will be doing it for one cycle. So first and the foremost, since it is a function, so for a function, if I want to write the domain means what all x values we can take in sine. So we can literally take all x values in sine, all real values of x. So domain is x belongs to R. Now the Sine value is fluctuating between 1 and -1. It will always fluctuate between 1 and -1. So whatever may be the sine, like whatever may be the angle inside the sine, you can put even 1000 also, it doesn't matter. When you're putting 1000, your mode should be in radians. So now just for understanding, you can just change the mode to radian and put any random big value inside the sine. Any random big value as big as you want to. Just put it and check the answer. The answer should always fluctuate between -1 to 1. So whatever answer you will get as per the value, it should be between -1 to 1. Okay?
Yeah, I put 4,521 and I got negative 0.245. Blah, blah,
Yes.
blah, blah.
Yes. So it means that it is evident from the graph also that the values will always fluctuate between these two lines. Lines means from -1 to 1. Okay. Value of a function is called as range. So I can just write down range of this sine is y belongs to -1 or y is greater than equal to -1 less than equal to 1. It can also be written like this: y belongs to -1 to 1. If anyone have doubt in the notations, please feel free to ask. I'm using the set notations over here to write down domain and range.
Yeah, that's it.
Wait, hold on, sir. Can you go back?
Where? Last slide?
No, nothing, sorry. Oh, wait, never mind. I understand. Wait, sorry. I was trying to look for a question, but I couldn't find one.
You have any doubt connected to this? Okay, so let's move on to the further analysis of this graph. Okay, we will be analyzing only one cycle. We'll be starting from 0. This is pi and this is 2 pi. Okay, once again I am back to radians because this is a graph. In the graph, it is wrong to write degrees. In some questions you may get it, but that doesn't mean you should write it. You should always write it down in the form of radians. So please be very clear, this pi will be 180, 2 pi will be 360. Okay, so sine have one complete cycle between 0 to 2 pi. It starts from 0, it rises to 1. It rises to the peak value at pi by 2. Along with understanding this graph, you can just put the values and check. You can verify what I'm saying. So you should put sine pi by 2 in your calculator and just check it out whether it is coming as 1 or not. And then you can also put sine 0 and sine pi. They will come out as 0 as it is seen in the graph. Now when we go back, when we go down from pi to 3 pi by 2, 3 pi by 2 means 270. It will reach -1. Put it in the calculator and check whether sine of 3 pi by 2 is negative or not. If anyone doesn't get, you can ask. Otherwise, you can just keep on putting it in the calculator. Okay. Now in this graph, what I have drawn is the 4 quadrants. Okay, I'll just highlight them. This is the first quadrant. We just discussed now only few moments before.
Sir, I'm getting -1.
-1 is correct. You can see in the graph. Can you see it is reaching till -1 as per the graph? So sine pi by 2 will be +1. Sine 3 pi by 2 will be -1. That is fine. Coming back to the quadrant, just have a look at the first quadrant. In the first quadrant, sine was positive. In fact, everyone was positive. So you can see it is lying above x-axis. Then coming to the second quadrant. Now second quadrant belongs to sine only. So that's why in the second quadrant also sine will be positive. Moving on. Third quadrant. Third quadrant belongs to whom? Can anyone tell me? You can see the diagram in your notebook and just tell me.
So sir, tan would be positive here.
Yeah, so third quadrant belongs to tan. So sine will be negative. That's why you can see in the graph that it went down. It went in the negative portion. everything below x-axis is negative. So this is the third quadrant. And finally, the fourth quadrant belongs to cos. So you can see this portion, this is still negative, and this is the fourth quadrant. So the graph of sine fluctuates between -1 to 1. It starts from 0, then it goes to 1. Then from 1, it falls down to 0. Then from 0, it falls down to -1. Then from -1, it come back to 0 again. So this is called as wave. Okay, this is a sine wave, and that will be there in physics also in the chapter oscillation and waves. Okay, so why we are calling it as an oscillation? Because it started from the mean position 0. After one complete oscillation, to and fro, this is to, and then this will be fro, going one side, then other side, and then coming back to the mean position. So 2 pi is one complete cycle. So between 0 to 2 pi, whatever we have done in sine, please observe it carefully. You should draw it along with me. Drawing graphs is there in our portion. Like there will be questions where you need to draw it. So please sketch it along with me only. And if there is any doubt, any question in this diagram, in this graph, feel free to ask now. Because of which sine and cos becomes complementary function. Just remember this name. I will use the name again and again in the upcoming lectures also. So y is equal to cos x. Once again, this is a similar type of fluctuating graph which starts from 1. It fluctuates like this. Okay, I'm drawing only one cycle, and remaining cycle I'll just show you so that you can understand that it will also be continued infinitely on both the directions. Okay, we need to analyze only one cycle. Just everyone observe and try to understand that this will be the one cycle of cos. It started from 1, this is 1, this is -1, okay, and then it came back to 1 again. One complete cycle will be from 0 to 2 pi. So the initial and end points will be same. Then this is the midpoint, which is pi. And this is the midpoint of 0 and pi. It's all symmetric. So we can just take the midpoints to get the values. This will be pi by 2 and this will be 3 pi by 2. So be quick and try to find the value of cos pi by 2, cos 3 pi by 2, and just see to it that it should come as 0. Okay, as it is seen in the graph also. Before moving ahead, I will write down the domain and range. So domain will be all x belongs to R, because literally there is no such real values which we can't put. We can put everything. So we'll say domain is x belongs to R. And when I say range, so range is same as sine because it also fluctuates between -1 to 1. Just for verification, put any big value as x in your calculator for cos, and you will get the answer between -1 to 1 only. Reason is same as what we did for sine. So I'll write y belongs to -1 to 1. So this is same for sine and cos. There is no difference. The only difference, if anyone have noticed, is this was the cycle for sine. This was the cycle for sine. And now the cycle for cos has been shifted by 90 degrees or by pi by 2 units. So that's why there's a difference of 90 degree in their angles. Because of that, they are called as complementary functions. Sine and cos are complementary functions. There will be many properties of sine and cos which are almost similar. Cos starts with 1. In the first quadrant, as it is seen, everyone was positive. So first quadrant, cos is also positive. But the second quadrant, as soon as it has to go down because second quadrant belongs to which trigonometric ratio?
Sine.
Second belongs to sine. So cos will be negative in that. Okay, negative means it will go below the x-axis. Look at the graph. Third quadrant belongs to tan. So in the third quadrant, as it is seen over here.
Why does it belong to tan?
Yes, late. Any doubt?
Yeah, why does it belong to tan?
Yeah, that belongs to tan. Because of that, cos is still negative. And the fourth quadrant belongs to cos only. That's why it will come up and it will become positive. It will start with 1, falling, falling, falling means it is decreasing. At pi by 2, it will become 0. From pi by 2, it will fall further up to -1. Okay, -1 is the lowest peak. Okay, then from -1, it will start rising again. Up to 3 pi by 2, it became 0. And then 3 pi by 2 to 2 pi, it will become 1 again. So all the values of cos is fluctuating between -1 and 1. So most of the things, if you observe, of sine and cos, they are same, they are similar, but just see the differences. And these pictures should be there in your mind, okay? Because when we will do the question over there, there will be some transformation also. So it shouldn't be that you're not clear with the basic graph of sine and cos. Tan graph, we will do it in the next lecture. Our next lecture, as per this week, will fall on Saturday. Saturday, I think, yeah, Saturday we can have it at the same time because your time is in the afternoon only. But next week, the classes will be mostly in the first half because schools will not be there. So it will be shifted in the morning. Will not change the days because there are lots of other classes. Okay, days will be same, but we'll shift the time. It will be in the first half. Okay, so before finalizing the time, if it will be possible, we'll definitely ask you for the options. Okay. So we'll make
Sir,
sure that in your winter vacation, you guys sleep more. Okay, so we'll not keep it too early in the morning. But yeah, it will be in the first half. Okay, so see you next for physics.
one question, sir.
Yes, late.
Tomorrow, is it possible for class